Hello, my friends. I'm Clover, and this is Genuinely Approachable Sudoku. You're probably a little bit surprised to see me today because we are not solving a Philip puzzle. I am one day early in the rotation. I'm solving a puzzle by Bill Murphy today instead, which is always a rare treat for me. Not that I don't enjoy Philip puzzles, but sometimes it's nice to change things up a little bit. Philip is taking a day off today. We have traded days in the rotation, so you will be seeing him later in this cycle. And I'm going to be solving this Bill puzzle with you. So what's going on here? So we have normal Sudoku rules. That means we'll be placing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. And then also we have zipper lines, and this is going to be a little bit different from the zipper lines puzzles that we have done on this channel in the past. And the reason is that in this puzzle, which I think is a first for this channel, we have actually a couple of even length zipper lines. Now, typically with zipper lines, if you have an odd length, that indicates that the sum of each pair of digits that's the same distance from the middle, so for example these two orange cells or these two blue cells, equals whatever digit is in the middle. So orange plus orange is 8, blue plus blue is also 8. If you have an even line, it works the same way, except because there is no exact middle cell. That means that you just haven't been given the total, but it's still the case that the sums of digits that are equidistant from the center have to be equal to each other. So in that case, this would mean the sum of these two digits, whatever it is, which could be as high as even 16, has to be the same as the sum of these two digits, which are also the same distance from the center. And we don't know what the sum is. It doesn't necessarily have to be a single digit sum. We just know that it has to be equal for these two pairs. So let's still start with what we have from kind of our familiar experience with zipper lines. So down here we have two pairs who sum to 6. And there are only two ways to make a sum of 6 with pairs of digits that can see each other. Those are going to be 1, 2, and, 1, 5, and 2 and 4. So the digits we're using are 1, 2, 4, 5. This can't be 5, so its counterpart cannot be 1, because 1 plus 5 is 6. A sum of 5 has to be 1 and 4, or 2 and 3. And so we'll pencil those in here. And that's kind of interesting, because now we can see that 6, 7, and 8 can't go in these cells, and they can't go in these cells because they see them. So these three digits will be 6, 7, and 8, and we can eliminate a few things there just based on what is in the rows already. These three will be 6, 7, 8 for the same reason on the opposite side of the grid, and I'll eliminate 6, 7, and 8 here. And then because of that, we have 6 and 8 here, 6 and 8 here. We know that these two digits have to be 6 and 8 in this column. There's nowhere else in the column to put 6 or 8. And because of the 6 here, we can place an 8 and place a 6. Very similarly, we need to place a 7 and an 8 here because there's nowhere else in this column they can go anymore. So they will have to go there and there. 6 is either 1 and 5 or 2 and 4. 7 normally has 3 options. In this case, it only has 2 because we can't use a 6. So the 7 can't be the sum of 1 plus 6. It has to be either 2 and 5 or 3 and 4. Now, what do we have left in these columns as they are rapidly filling up? So we still need to place a 9 in these columns. So let's consider where we can put a 9 in this column and where we can put a 9 in this column. So 9 cannot be part of a sum that only sums to 8. We would have to sum it with -1. There's no -1 in this Sudoku, so we definitely can't put a 9 there. Now, could 9 be here? I said a little bit cheekily earlier when I was introducing this variant that this sum could be 16, and in fact, if we were to put a 9 here, this would end up with a sum of 16. However, there is a problem with that. We would also need these two cells to sum to 16. The only way for that to happen using Sudoku digits that are able to see each other in the same row is for that sum to be 7 plus 9, but we can't very well make these two outside cells also be 7 and 9, then we would have two 7s and two 9s in the row. So that's also not going to work for 9. But we still need to put a 9 somewhere in column 2. It can't go anywhere down here, we figured that out, so it must go right here, making this a 3. Now the only remaining digits are 1, 2, 3, and 4 in the column, and we can eliminate 3, and that tells us that in column 2, the 3 has to be in one of these cells. In other words, a 3 is involved in the sum to 5. So the sum to 5 is 2 plus 3, and we can eliminate a 2 there. And we can make this a 2-5 pair. Couple things we can do here. There's a 5 right there, so that's a 2, that is a 5. Also, we can now eliminate 2, 3, and 5 from this cell, making it a 4, which tells us this is a 3. And also, this column only needs 2 more digits, a 1 and a 9. This one only needs 2 more digits to finish the region, a 2 and a 5. So now let's have a look at this zipper line. 8 is equal to 5 plus 3, so I'm going to place a 3 there. And that has eliminated 3 from actually almost all positions in this region, because we have 3s here and here. And we know we can't have a 3 over here because that's our 6, 7, 8 triple, so our 3 goes right there. And this is not a 2, 3 pair, it is a 1, 4 pair. The 1, 4 pair makes this a 2, and 2 plus what is 6? That's going to be 2 plus 4. So we know that the outer sum here is 1 plus 5, and we get to eliminate a 2 here in the same row, so that's now a 3, and this will be a 2. These digits are going to be 3 plus 9. This, I mean, there are a few ways to see this. I think this is simpler. We could do the same thing with 7 and 9 that we did up in the top left corner, if you're recalling that when you're looking at this. But you could also say, well, a sum that includes an 8 has to be bigger than 8, so that must be a 9. 8 plus 1 is 9. So that gives us a 1 here, which resolves the 1, 5 pair. We can now eliminate 1 and 5 from here, so this can no longer be a 1, 5 pair. It must be a 2, 4 pair, making this a 5 and making this a 2. This is going to be a 4 to finish the region, making that a 2 and a 4. And now we finally get to work with this because the sum of these two cells is 10. Therefore, the sum of these two cells is 10. That makes this a 6 because 6 plus 4 is 10. And placing that 6 is going to resolve that left column over here. Now, to finish this region, we need 1, 3, 5, and 9. Now, this cell sees a 3, a 1, and a 5, so it is a 9. This one sees a 1 and 5, so it is a 3, and these can't be 3 or 9. These cells to finish off this column are going to be 2 and 9, which resolve because we already have a 9 in row 3. Now, what are we going to do to finish this? I really should have done this earlier. I did notice this when I was working earlier, but I got distracted and moved on. But now we're coming back to it. 8 can't be 4 plus something, because it would be 4 plus 4, and that would give us 2 4s in the top row. So it must be 1 plus 7, which places a 6 there and a 4 there, and in fact resolves this entire region. Now we have a 4 here. That means that the sum for this region sum line is 4 plus 7, which is 11. 2 plus what is 11? 2 plus 9. So we finish that with a 9. Finish the row with a 2 here. Finish the row here with a 1 and a 6. And finish the row here with a 4, 5, and 8 that we can't yet resolve. We're now going to finish this row with an 8 and a 9 right there and there. We're going to finish this row with a 1, a 2, and a 9, which resolve based on what we already have in the grid. Finish this region with a 4. These are going to be 3, 5, and 7. And really we just have classic Sudoku left to perform, so let's get through it. To finish this row, we're going to need 1, 2, 5, and 6. 3 of those 4 digits are here, so this is a naked 5. And these also resolve. This sees a 1, 6, and 5, so that's a 2. That's now a 6. The 5 makes that an 8. And eliminates 5 from here. These cells are going to be 3, 7, and 9 in the column. This one already sees a 3 and a 7, so that gives us a 9, which resolves this 1, 9 pair. These are going to be 1, 3, and 7. This cell sees a 1 and 3 in its column, so that's a 7, that's a 3, and I think we can finish up now. Lovely Sudoku from Bill Murphy. Always a pleasure to get to solve a Bill puzzle. It's a little unusual for me. I really enjoyed it. If you want to try it yourself, the link to do so is in the link directly below this video. And go ahead and give this one a shot, and I will see you in a couple of days.